Good morning, grade 12 physical sciences learners. The second audio on rates of reactions. Then today we are dealing with the nature of reacting substances. We are going to consider these reactants in solid phase, in liquid phase, and in gaseous phase. For example, if we are dissolving sodium in water in solid phase, or dissolving sodium in water in liquid phase, or dissolving sodium in water in gaseous phase, reaction is faster in gas phase rather than in liquid phase. Reaction rate is faster in liquid phase rather than in solid phase. Reaction rate is faster in gaseous phase rather than in liquid phase. Reaction rate is faster in liquid phase rather than in solid phase. Ions in solution react faster than solids or liquids. Ions in solutions react faster than in solids or liquids. Another example, smaller molecules are faster than larger molecules. That's why you have to cut even your potato. It's faster the one that is smaller than the one that is larger. Smaller molecules are faster than larger molecules. Then another factor is the pressure. If pressure is increased, the rate of a reaction increases. If pressure is increased, the rate of a reaction increases. The more pressure exerted, the more the rate of a reaction. The more pressure exerted, the more the rate of a reaction. Then the last factor is the catalyst. The last factor is the catalyst. The catalyst is a substance that increases the rate of a chemical reaction without chemically participating in the chemical reaction. The catalyst is a substance that increases the rate of a chemical reaction without chemically participating in the chemical reaction. The catalyst reduces the amount of energy that is needed to break the bonds in the reactants. The catalyst reduces the amount of energy that is needed to break the bonds in the reactants. Let me remind you of grade 11 work. The catalyst decreases the total activation energy. The catalyst decreases the total activation energy. Catalysts do not change the enthalpy of a reaction. Catalysts do not change the enthalpy of a reaction. Catalysts do not affect the amount of product formed, only the speed at which these products are formed. Catalysts do not affect the amount of product formed, only the speed at which these products are formed. Catalysts do not affect the amount of products formed, only the speed at which these products are formed. Two forms of catalysts: homogeneous catalyst, heterogeneous catalyst. When talking of homogeneous catalyst, is when the catalysts and reactants are in the same phase. When talking of homogeneous catalyst, is when the catalysts and reactants are in the same phase. For example, in the first term, that reaction of forming of ester alcohol reacting with carboxylic acid in the presence of a catalyst, a concentrated sulfuric acid, so they are in the same phase. So that's when you talk of homogeneous catalyst. Then with regard to heterogeneous catalyst, catalysts and reactants are not in the same phase. Catalysts and reactants are not in the same phase. So in the Haber process, reactants are in gaseous phase, and then the catalyst ion is in solid phase. In the Haber process, the reactants are in gaseous phase, and then the catalyst solid ion is in solid form. Then for this particular topic, you must work out examples in your textbooks and study guides. Thank you.